Hello everyone, welcome to another exciting math problem of the week involving counting, suitable for beginners. Here is the problem. Calculate the maximum size of subsets from 1, 2, 3, all the way to 20, where no element is a divisor of another within the subset. The options are A 8, B 9, C 10, and D 11. Before we uncover the solution, I encourage you to hit the pause button, grab your pen and paper, and give it your best shot. When you're ready, feel free to share your answers in the comments. Then we'll explore the solution together. Let's get started. Let's approach this with some strategy, try and error. Choosing 1 as an element in this subset immediately limits us, as 1 is a divisor of any integer. Moving on, if we include the number 2 in our subset, we can also include 3, but we must exclude 4 and any other even numbers. Continuing in this manner, we include all prime numbers up to 20, which are 2, 3, 5, 7, 11, 13, 17, and 19, giving us a total of 8 elements. These two sets are considered maximal sets because no other set in the collection contains them as a proper subset. But are these maximal sets also the minimum sets? Meaning a subset with more than 8 elements where no element is a divisor of another? We can explore a trade-off strategy by replacing the element 2 and 3 with 4, 6, and 9. Getting a subset with 9 elements. Alternatively, choosing numbers from the largest to smallest. We could select the subset 20, 19, 18, all the way to 11, which adheres to our divisibility condition and result in a set with 10 elements. This raises a question. Is it possible to perform a trade-off to obtain an even larger subset? Feel free to explore this before we move on to the answer. Now, let's dive into the combinatorial argument. Any positive integer can be expressed as 2 to the power of k times m, where m is an odd number. Let's apply this representation to the integers from 1 to 20. For instance, 4 is 2 power 2 times 1. 10 is 2 power 1 times 5. 13 is 2 to the power 0 times 13. And 18 is 2 to the power 1 times 9. Focusing on the odd number n, which range from 1 to 19 for our integers. We group all integers with the same m value. For example, integers with m value 1 are 1, 2, 4, 8, and 16. They are all grouped together. Following this process for other m value, we find that within each group, one element is always a divisor of another. Given our condition, we can select at most one element from each group. With 10 groups in total, our subset can have at most 10 elements. Even with strategy trade-off, such as replacing 16 with 8 and 14 with 7, the size of our subset remains unchanged. Therefore, the correct answer to our problem is C, 10. Thank you to everyone who submitted their responses. Approximately 70% of you arrived at the correct solution. It's exciting to see different methods and solutions applied to this problem. Thank you everyone for participating in this math challenge. Stay tuned for more intriguing math problems. This concludes today's lesson. I hope you found this video insightful and are looking forward to more mathematical adventures. Until next time, take care and bye-bye.